Okay, so for this lesson, we're going to be talking about arithmetic sequences. A sequence is really just a pattern of numbers. When they take a specific pattern, like you're adding by something over and over, or you're dividing by something over and over again, or you're multiplying by something over and over again, that's when they fit the form of an arithmetic or a geometric sequence. Today, we're going to be focusing on arithmetic sequences that have a common difference. The reason why it's called a common difference is because if you ever take the difference between two terms that are next to each other, you should always get the same value. So for example, if you do 7 minus 3, you get a value of 4. Or if you do 11 minus 7, you get a value of 4. That 4 is our common difference. Another way to look at it is what are you adding or subtracting by to get from term to term. So that common difference comes out to be 4. Okay, so to write an explicit definition for an arithmetic sequence, this is the formula you'll need to remember. A sub n stands for the nth term, okay? So that's some unknown term in the sequence. You're always going to begin by adding your very first term. A1 in this particular case would be 3. That's the very first term that I have in my series. My second term would be A2, my third term would be A3, my fourth term would be A4, and so on and so forth until I get to the nth term. Okay, so for an arithmetic sequence, you're always going to start with the very first term. It's basically as if you're doing 3 plus 4 over and over and over again. Okay, so 3 plus 4. Now the thing that's going to happen is that you're going to be multiplying that n minus 1 times to get to the nth term. Okay, so one less than the amount of terms you're trying to get to. So the general formula is a sub n equals a sub 1, our first term, plus common difference multiplied by n minus 1. Okay, you're going to want to make sure that you remember this formula or write this down because you're going to use this many times throughout the lesson for today. Okay, so first thing we want to do is make sure we understand how do you identify if something is an arithmetic sequence. Again, you're looking for this idea of a common difference. It could be that it's a negative common difference, like if you're subtracting by the same thing over and over again. You definitely want to make sure it's not that you're multiplying or some other kind of pattern. So let's take a look at question number 1. As I go from 5 to 11, I'm adding by 6, and 11 to 17, I'm adding by 6, and so on and so forth. So you can see with the fact that I'm adding by 6 over and over, yes, this is geometric, and it has a common difference equal to 6. Okay, so now that we can do that, now I want to write an explicit definition for this. My first term is the first term in the sequence, 5, and I'm going to use this model that we just talked about before. A sub n equals a1 plus d times n minus 1. Okay, so a sub n, you're going to leave as a sub n. You don't plug anything in for that because, again, you're trying to make a formula for this. A1 is the 5 that I have over here. Okay, so 5 plus, and then you're going to I'm going to put it where n minus 1 comes first, and then I'll put the 6 after it. Okay, so this is your common difference. This is your very first term. Okay, and you're multiplying that by n minus 1. Okay, this has now made a formula for this pattern. So if you wanted to find, let's say, the 57th term, and you didn't want to sit there and do plus 6 plus 6 plus 6 over and over, that's how you'd be able to get to the 57th term. You could just plug in n equals 57. Okay, take a look at the second example. If I try to look at me adding by the same amount, I'm adding by 4, but then I'm adding by 8, I don't have a common difference, so no, this is not an arithmetic sequence. Eventually you will see that it turns out for this one that we're actually multiplying by 2 each time, and when you're multiplying by something, we're going to refer to that tomorrow as a geometric sequence. So if you take a look at question number 3, to go from 20 to 16, I'm minusing 4, and from 16 to 12, I'm minusing 4, and 12 to 8, I'm minusing 4. So even though it's a negative common difference, I do still have a common difference of negative 4. So once again, I'll go back to my formula up top. A sub n equals a1, in this case, a1 equals 20. So 20 plus n minus 1 times my common difference, which is negative 4. I moved the common difference, by the way, to the end because I don't want anybody to ever accidentally add 5 plus 6 or 20 plus negative 4 or something like that. When you look at the last example, you're adding by 3, and then you're adding by 5, and then you're adding by 7. Clearly not a common difference. This one does not come out to be arithmetic or geometric. You don't have to worry about exactly what it is. Right now, we're just trying to get to arithmetic sequences. So what's the purpose of making a rule for an arithmetic sequence? So that you can find a specific term in that sequence. Okay, so that's what's going to be happening in questions 5 and 6. So if you take a look at question number 5, to go from 6 to 10, I'm adding by 4, and 10 to 14, I'm adding by 4, so I have a common difference equal to 4. My very first term is 6. So if I make a rule, a sub n equals a1 plus n minus 1d. I'll plug in, I have a sub n equals 6, that's my first term, plus n minus 1 times my common difference, 4. So in this particular question, they're asking us to find a sub 20. So what that means is plug in n equals 20. So a sub 20 is equal to 6 plus 20 minus 1 multiplied by 4. You can go ahead and plug that whole thing right in your calculator, and you'll find out that the 20th term now is 82. Okay? Without having to go and add from the first term plus 4 plus 4 plus 4 plus 4 19 times to get to the 20th term. Okay? You'll notice in the next example it says f of 13. You can still just think of that as a sub 13. So in this case, if you wanted to find the 13th term, you would still have to identify, okay, what kind of pattern is this? Is it arithmetic? Well, you'll notice this time I have a common difference of negative 4. Okay, again, it's totally fine to have a common difference that's negative. What's your first term? Your first term is 10. To make the nth term, a sub n is equal to my first term, which is 10, plus n minus 1 times the common difference of negative 4. In this case, you're going to be solving for when n equals 13. That's what this information means. Okay, so even when it had been the 13 inside the function notation, it still means the same thing. So the 13th term is going to come from doing 10 plus 13 minus 1 multiplied by negative 4. And once again, you can go right to plugging that right in your calculator and see that that comes out to be negative 38. Technically, okay, and that's the reason why this one had this notation, is that sequences are really just functions. So let's take a look at what kind of a function is an arithmetic sequence. A big hint to you is the fact that you have a common difference, so a common rate of change. So let's take a look. Okay, so consider the last sequence from problem number 6, the one that went 10, 6, negative 2, etc. Okay, so this is my function values, 10, 6, 2, negative 2. If I kept going with that pattern, that would be negative 6, negative 10. This one, okay, if again, I'm looking at this example in number 6. My first term had been 10. My second term had been 6. My third term had been 2. So when I plugged in n equals 1, I got 10. When I plugged in 2, I got 6, 3, 4, 5. Don't worry, you're not going to have to actually do this yourself. This is just to show you, what happened or what kind of relationship an arithmetic sequence is really like. So let me go and plot this on my grid. So if I plot the point, 1, 10, and 2, 6, and 3, 2, okay, and 4, negative 2, 5, negative 6, and finally 6, negative 10. Okay, don't connect the dots, because that's the big thing that's different between functions and sequences. In sequences, okay, you can only plug in whole numbers. I can't plug in 1.5 or 2.5 or 3.5, so there's no graph at 1.5 or 2.5 or 3.5. Okay, you can only plug in these specific points. However, if you could connect them with some sort of a function, what kind of a function would it be? Okay, so again, remember, don't connect the points. But what relationship do you see? You should see that it comes out to be linear. Okay, so that's the main idea, is that arithmetic sequences are really linear functions. Okay, the biggest difference is that in an arithmetic sequence, the domain is only positive whole numbers. Okay, whereas with linear functions, the domain is all real numbers. Okay, that's like the biggest difference between the two. But I want you to remember this relationship. Arithmetic sequences are really linear functions. So how can that be helpful? Well, if you take a look at the example that we just went through, let's say I had to get from this one point to this 1 point. What slope would I be using? Remember that slope is change in y over change in x. So you'll notice in this case, that means I'm going down 4 over 1. And you can see that the slope is really the common difference. So if you take a look a little lower, okay, look at question number 7. It says, given a term in the arithmetic sequence and the common difference, find, I'm sorry, you know what? I'm going to skip ahead for a second. Go to question number 9. Write an explicit definition for the nth term of each arithmetic sequence given the two terms. Okay, so basically what's happening here, you know that this is an arithmetic sequence. Arithmetic sequences are basically like linear functions. We just came up with the idea that the slope is the common difference. That's the d value that we're looking for when we want to make the equation of an arithmetic sequence. So if you take a look in this problem, we need, if to be able to make the explicit definition, a sub n equals a1 plus n minus 1d, we're missing the first term and we're missing the common difference. Okay, so since I know it's an arithmetic sequence, to find the common difference, I'm going to find the slope. So maybe what might help you is if you rewrite this as the point 4 comma 36, instead of thinking of it as a sub 4 equals 36, and 9 comma 61, now you can use this and you can calculate the slope and then use that to make the equation of your expression. So you're going to do your slope, or your common difference, okay, is equal to change in y, so 61 minus 36, over change in x, 9 minus 4. When you evaluate this, you can see this comes out to be 25 over 5, or a common difference of 5. Okay, so you have your common difference now. So you have what's going to go right here in that spot for D. All right, we'll take that common difference, take any one of these points, and you can use that to work backwards to get to the first term, or I'll show you a backup way in just a second. Okay, so our general formula is a sub n equals a1 plus n minus 1d. Let's talk about using this point right here, a sub 4 equals 36, to help us out. So our a sub n is really the 36. That's like the fourth term of this series. a1 we don't know. To get 36, we had to plug in n equals 4, so 4 minus 1 goes in parentheses, and we just solved that our d value comes out to be 5. As I clean this up a little bit, if I do 4 minus 1 times 5, that comes out to be 15, or 3 times 5, and you'll notice that just minusing 15, I'm now able to figure out that my very first term was a sub 1. So putting that all back together, a sub n equals a1, okay, so a1 is 21, plus n minus 1 multiplied by d that we found before, and now I have a rule to represent this arithmetic sequence pattern, starting with two totally different points on the sequence, and not having the common difference, not having the first term, but able to work backwards to get that first term and that common difference. So again, what's the big important thing from this? The slope is the common difference. Let's try one more example of this, okay? So to figure out the d value, I'm going to think of this as the point 3 comma 94 and 20 comma 43, and I'm going to start by figuring out what is the slope, what is the common difference. So if I do slope, I'm doing 43 minus 94, watch your direction, 43 minus 94, 20 minus 3, you have to make sure you're going the same direction, and you'll find that in this case, you have a slope that comes out to be negative 3. Okay, so a sub n equals a1 plus n minus 1d is our rule for an arithmetic sequence that we're going to use to find that missing term. Okay, so pick any one of these terms. So this f of 3 equals 94, think of that as a sub 3 equals 94. Okay, so the third term is 94. The first term, I don't know. We plugged in n equals 3 to get here, so that's why it's 3 minus 1, and we're going to use that d value we just solved for as negative 3. Should be a relatively simple equation after you plug in. So our a1 gets added to negative 6. And when I add 6 to both sides, I find out that 100 is my first term. So if I put it all back together, a sub n equals 100, my first term, plus n minus 1, times negative 3, my common difference. I had mentioned there's also a backup way of being able to find A1 if you don't like doing this whole kind of solving problem down here below. If you know that the third term is 94, okay, so here's your third term. And you know each time you had to minus 3 to get to that term, okay, so maybe I'll do that in a different color to make that stand out. Each time you had to minus 3 from the previous number to be able to get to that term. What was the value for A2? Well, think about what minus 3 was 94. You would figure out that that came out to be 97. Okay? Did I do that right? I think so. And then you'd say, okay, well, what minus 3? Yeah. What minus 3 came out to be 97? Okay, you would see that comes out to be 100. And that once again shows you that A1 equals 100 if you don't like doing this process of solving the equation below. Just to do one quick word example. Dave is developing a fitness plan that includes doing push-ups each day. On each day the first week he did 20 push-ups. Each subsequent week he increased his daily push-ups by 5. He's increasing by a constant change or a common difference of 5. During which week did he do 60 push-ups per day? Okay, so he did 20 push-ups in the first week, meaning A1 equals 20. If I use my geometric sequence formula, A sub n equals A1 plus n minus 1 times d, okay, I want to find out when A sub n was 60. Okay, what number of weeks did it take for him to do 60 push-ups per day? So 60 is A sub n, A1 is equal to 20, n I don't know, common difference I was told is 5, and now I just solve this like a regular equation. Now normally you could distribute and combine like terms, but I'm just going to do something a little different today. I'm going to start by minusing the 20 from both sides. That gives me 40 equals n minus 1 times 5. And rather than distribute and solve, which you can definitely do, I'm going to go right to dividing both sides by 5. So this tells me that 8 is equal to n minus 1. And when I add 1 to both sides, I now know it takes him 9 weeks to get to the point where he is doing 60 push-ups per day. Okay, and again, that's based on the fact that I have a constant difference, and that's what tells me it's an arithmetic sequence.